Welcome to my channel, Brain Encoded. Today, I want to invite you on a journey inside your skull. You may not realize it yet, but within that biological computer of yours lies untapped potential, massive flexibility, and new frontiers of performance waiting to be accessed. If you're ready to unlock your mind and elevate your brain power, then you've come to exactly the right place. In this video, Unlock Your Mind, Ultimate Guide to Brain Power, we're going to explore how your brain actually works, how you can strengthen it, how you can reshape it, and how you can harness it to think sharper, focus deeper, learn faster. Let's get started. Let's talk about the most powerful and transformative property your brain has, its ability to change itself. Neuroplasticity is the biological mechanism that allows your brain to reorganize, rewire, and even grow new connections in response to experience. It's the reason why your mind is not fixed, why your intelligence, your focus, and your creativity are not static, and why the limitations you perceive are far more malleable than you think. This is not theory, it is hardwired into the very structure of your neurons. Every thought you have, every action you take, every new skill you learn is physically reshaping the wiring of your brain. At the core of neuroplasticity are neurons, the specialized cells that transmit information through electrical and chemical signals. But neurons don't work in isolation, they form networks, complex circuits that govern everything from reflexes to higher cognition. When you repeatedly engage in a specific behavior or thought pattern, those networks strengthen. The axons and dendrites that carry signals begin to form stronger, more efficient connections. This is often summarized as neurons that fire together, wire together, but it's more than a catchy phrase. It's the operating principle of your brain's adaptability. Each time you practice a new skill, read a challenging book, or focus deeply on a problem, you are physically remodeling your brain's architecture. You are laying down new pathways, reinforcing them, and pruning away the circuits that are less used. But neuroplasticity is not passive. It is a process that requires intention and repetition. Sporadic effort, brief exposure, or half-hearted attempts at learning will not generate the structural changes needed to reach higher cognitive function. Instead, the brain responds most effectively to consistent, meaningful, and emotionally salient experiences. Your attention, your emotional engagement, and your motivation serve as the fuel for neuroplastic change. When you are curious, when you are challenged, when your brain perceives that what you are doing matters, plasticity is amplified. Conversely, stress, distraction, and lack of sleep suppress it, making the same effort less effective. One of the most striking aspects of neuroplasticity is that it occurs across the lifespan. While children's brains are famously flexible, adults retain the capacity for profound change. Even in later life, learning a new skill, engaging in complex problem solving, or adopting new habits can generate measurable growth in neural circuits. This is why the concept of "it's too late" is largely a myth when it comes to the brain. Age does not rigidly define your cognitive ceiling. Your brain is a dynamic, living organ capable of rewiring itself in response to the right inputs, even decades after development. The mechanisms underlying neuroplasticity are diverse. Synaptic plasticity, for instance, refers to changes in the strength of the connections between neurons. Long-term potentiation strengthens the synapses that are used most often, while less used pathways weaken or disappear. Structural plasticity involves the growth of dendritic spines, the tiny protrusions on neurons that receive input. Myelination, another key mechanism, increases the speed of signal transmission along frequently used pathways. All of these processes are responsive to behavior. The simple act of repeated practice, when paired with attention and intention, can literally alter your neural landscape, enhancing memory, learning capacity, focus, and emotional resilience. Practical application of neuroplasticity is both straightforward and subtle. It begins with awareness. Recognize the habits, thought patterns, and behaviors you want to strengthen. Then design your life around repeated, meaningful engagement in these patterns. Create small, achievable goals that challenge your brain without overwhelming it. Track your progress. Use focused, high-intensity periods of practice followed by recovery, because the brain consolidates change during rest and sleep. Environmental factors also matter. Exposure to novelty, movement, and even controlled stressors can enhance plasticity. Essentially, every deliberate action you take is an opportunity to guide the brain's rewiring toward outcomes you desire. Understanding neuroplasticity is liberating because it shifts responsibility and opportunity squarely into your hands. You are not bound by the intelligence you were born with, the habits you fell into, or the environment you inhabit. Every deliberate thought, every focused practice session, every small step of mastery is reshaping your brain. Over time, these incremental changes accumulate, producing profound transformations in cognition, emotion, and behavior. Your potential is literally a function of how effectively you engage the adaptive power of your own neural circuits. Neuroplasticity is your gateway, the door through which you move from who you are today to who you are capable of becoming. It is the reason you can learn faster, think more creatively, and recover from setbacks with resilience. The power to rewire your mind is not abstract. It is within your grasp, waiting for consistent, intentional, and emotionally engaged action. In every moment, your brain is listening, adapting, and evolving. Your responsibility and your opportunity is to give it the right inputs. Our brain does not function in isolation. It is intricately connected to the body, and its performance is directly shaped by the state of your physiology. Every thought, every decision, every moment of focus is supported or limited by factors like sleep, movement, nutrition, hydration, and the environment in which you operate. If your goal is to elevate cognitive performance, enhance learning, or unlock mental clarity, you must first understand that optimizing your physiology is not optional, it is foundational. The brain consumes energy at a staggering rate, and it operates most efficiently when its underlying systems are well regulated. Sleep is the first, most critical lever. During sleep, the brain engages in processes that are essential for cognition. It consolidates memories, clears metabolic waste, restores neurotransmitter balance, and recalibrates emotional circuits. Lack of sleep or disrupted sleep not only impairs focus and memory the next day, but also reduces neuroplasticity, making learning less effective. Studies show that even a single night of insufficient sleep diminishes attention, reduces problem-solving ability, and compromises emotional regulation. Conversely, regular, high-quality sleep enhances memory retention, supports creativity, and strengthens the synaptic connections that underpin learning. Prioritizing sleep is not a luxury, it is the physiological foundation upon which every cognitive skill is built. Movement is another non-negotiable factor. The act of moving your body, whether through aerobic exercise, resistance training, or even short bouts of walking, directly influences brain health. Blood flow, oxygen delivery, and neurotrophic factors such as BDNF, brain-derived neurotrophic factor, increase during movement. These factors promote the growth and survival of neurons, strengthen synapses, and enhance overall cognitive performance. In practical terms, even a daily 20-30 minute brisk walk can significantly enhance focus, learning capacity, and mental clarity. Movement is not just about physical health, it is a cognitive amplifier. If you neglect this, your brain operates at a diminished capacity, regardless of your effort or intention. Nutrition provides the fuel and building blocks your brain requires. The brain is highly metabolically active, consuming roughly 20% of the body's energy. A steady supply of high-quality nutrients supports neurotransmitter production, maintains membrane integrity, and protects against oxidative stress. Diets rich in omega-3 fatty acids, antioxidants, and vitamins promote neuroplasticity and improve memory, while highly processed foods, excessive sugar, and chronic dehydration impair cognitive function. Timing also matters. Fasting, nutrient timing, and avoiding late-night heavy meals can modulate alertness and clarity. You cannot expect peak cognitive performance on poor fuel. What you consume directly affects what your brain is capable of producing. Stress management is equally critical. Acute stress can transiently enhance alertness, but chronic stress impairs prefrontal cortex function, diminishes working memory, and reduces learning capacity. Physiological stress triggers cortisol release, which, in excess, damages synaptic connections and impairs neuroplasticity. Practices that regulate stress, such as controlled breathing, meditation, exposure to natural light, and periods of relaxation, restore balance and enhance brain performance. By learning to modulate stress physiologically, you create an internal environment where focus, creativity, and problem-solving flourish. Environment also shapes cognition. Natural light exposure, especially in the morning, sets circadian rhythms that influence alertness, hormone balance, and sleep quality. Temperature, air quality, and even the presence of greenery can influence mood, concentration, and cognitive stamina. Simple environmental adjustments, optimizing lighting, reducing clutter, and incorporating movement breaks, have outsized effects on mental performance. The brain is exquisitely sensitive to context. Optimizing your surroundings is a form of physiological enhancement. Hydration cannot be overlooked. The brain is approximately 75% water, and even mild dehydration affects attention, working memory, and mood. Drinking water consistently throughout the day, avoiding excessive caffeine or alcohol, and replenishing electrolytes after exercise are simple yet powerful ways to maintain cognitive sharpness. Hydration interacts synergistically with sleep, nutrition, and movement to sustain optimal brain function. Optimizing physiology is not about extreme measures, it is about alignment. Sleep, movement, nutrition, hydration, stress regulation, and environmental cues interact dynamically. When each element is tuned, the brain operates in an amplified state. Neurons fire efficiently, circuits strengthen, attention deepens, and learning accelerates. When any one of these systems is compromised, cognitive performance falters, no matter how motivated or intelligent you may be. The key takeaway is this: your brain's capacity is inseparable from your body's state. Focus on the levers you can control: sleep, movement, nutrition, hydration, stress, and environment, and your cognitive output will improve dramatically. This is not abstract advice, it is hardwired biology. To think better, learn faster, and perform optimally, begin with your physiology. Your brain's power is waiting to be unlocked, and the first step is to treat your body as the foundation for the mind it sustains. Learning is not simply the passive absorption of information. Your brain is not a sponge that soaks up everything in your environment. It is an active, dynamic organ that encodes, stores, and retrieves information through complex, energy-dependent processes. To truly unlock your brain's capacity, you must engage intentional learning and memory systems, mechanisms that are both measurable and manipulable. Understanding these systems allows you to take control over what you learn, how you retain it, and how efficiently you can access it when needed. At the core of intentional learning is attention. Attention is the gatekeeper of memory. If your brain is not focused, if your senses are scattered across multiple stimuli, information fails to consolidate into long-term memory. Neuroscience shows that learning is most effective when you direct deep, uninterrupted attention to a task. This is why multitasking is a cognitive trap. It prevents your neurons from firing together in coordinated patterns, reducing the efficiency of synaptic strengthening. Instead, structured periods of focused engagement, what some call deep work, create the neural conditions for durable memory formation. Once attention is engaged, encoding becomes critical. Encoding is the process by which perceived information is transformed into a lasting neural representation. Not all encoding is equal. Active engagement, emotional relevance, and contextual cues amplify the strength of memory traces. For example, when you relate new information to something you already know, or when you actively practice retrieval shortly after learning, your brain strengthens synaptic connections and stabilizes networks that support recall. Passive repetition, by contrast, is far less effective. It may create familiarity, but it rarely builds robust memory networks. To optimize encoding, you must be deliberate, use visualization, association, and varied modalities, reading, listening, speaking, writing, and doing, to reinforce the material across multiple pathways. Memory consolidation, the process by which encoded information is stabilized for long-term storage, is heavily dependent on both rest and repetition. Sleep, particularly the deep stages of non-REM sleep, facilitates the transfer of memories from short-term storage in the hippocampus to long-term cortical networks. Without sufficient sleep, even well-encoded information fails to solidify. Repetition spaced over time, known as spaced learning, leverages the natural rhythms of consolidation. By revisiting material at optimal intervals, you allow synapses to strengthen and stabilize, creating durable pathways for recall. Cramming may work for short-term performance, but it is fundamentally inefficient and fragile compared to intentional, spaced, and emotionally engaged learning. Retrieval is the final and often overlooked component of intentional learning. Practicing recall actively, testing yourself rather than passively reviewing, is one of the most powerful ways to reinforce memory. Every act of retrieval strengthens the relevant neural circuits and primes the brain to access that information more efficiently in the future. This is why flashcards, self-quizzing, and teaching material to someone else are far more effective than rereading notes. Retrieval not only tests what you know, it consolidates and deepens the learning itself. Intentional learning also benefits from environmental and physiological support. Light exposure, movement, and arousal states all interact with attention and memory circuits. A brisk walk before studying, a well-lit workspace, and a calm yet alert mental state enhance synaptic plasticity, making encoding more effective. Conversely, stress, fatigue, and distraction degrade these processes, creating a hostile environment for durable learning. By managing your internal state and optimizing your environment, you amplify the brain's natural learning mechanisms. Finally, learning is most powerful when it is purposeful. The brain is highly sensitive to goals and relevance. Information connected to personal objectives, intrinsic curiosity, or emotional salience is prioritized for encoding and consolidation. Motivation is not just a psychological phenomenon, it is a biological signal that triggers neuromodulators, like dopamine, which enhance plasticity, attention, and memory. When you learn with intention, guided by clear purpose and curiosity, your brain naturally engages the circuits required for long-lasting retention and flexible application. Engaging your intentional learning and memory systems is therefore a multi-dimensional process. It begins with focus and attention, is strengthened through active encoding and spaced repetition, solidified through sleep and retrieval, and amplified by physiological and environmental optimization. By understanding these mechanisms and applying them deliberately, you take control over your cognitive growth, creating a brain capable of rapid learning, deep understanding, and efficient recall. The brain's potential for learning is immense, but it is not automatic. It requires deliberate, intentional action. Every moment you focus, every act of retrieval, every effort to connect information meaningfully is a step toward mastering the neural circuits that support memory and cognition. By engaging these systems intentionally, you transform learning from a passive experience into an active, high-yield process that continually rewires your brain, strengthens your capabilities, and expands the boundaries of what you can achieve. The most overlooked yet most powerful lever for cognitive performance is your mindset. The way you approach challenges, setbacks, and opportunities has a direct and measurable impact on how your brain functions. Your mindset shapes your perception of what is possible, influences your motivation, and ultimately governs the neural circuits that control attention, learning, and memory. Attention is the currency of the brain. Where it goes, neural resources follow. And mindset determines where your attention flows, how it is sustained, and how effectively it drives performance. Let's start with mindset. A fixed mindset, the belief that your abilities are static, that intelligence or talent is predetermined, limits the engagement of neural circuits that support learning and growth. When the brain interprets difficulty as failure, stress circuits are activated, cortisol levels rise, and focus is disrupted. Neuroplasticity is reduced. In contrast, a growth-oriented mindset, believing that skills and intelligence can be developed through effort, engages the prefrontal cortex, facilitates learning, and promotes adaptive changes in the brain. This is not abstract psychology, it is neurobiology, believing that challenges are opportunities primes your brain to fire in patterns that strengthen learning, enhance problem solving, and increase resilience. Attention is the operational mechanism through which mindset exerts influence. Attention is selective, limited, and powerful. Your brain can only focus on a few things at a time, and what it chooses to prioritize shapes neural connectivity. High-level cognitive functions such as reasoning, problem solving, and memory consolidation depend on sustained, purposeful attention. Distraction, whether digital, environmental, or internal, scatters your neural resources, fragmenting circuits and reducing efficiency. Training your attention through deliberate practice, mindfulness, or structured focus sessions strengthens the networks that govern executive function and working memory. Attention and mindset are intertwined. A mindset oriented toward growth enhances attention because you perceive challenges as worth your energy. Conversely, cultivating attentional control reinforces mindset by creating experiences of competence, mastery, and progress. The brain rewards success with dopamine, and even small wins increase motivation, deepen engagement, and amplify learning. By consciously directing your attention, you create feedback loops that strengthen both cognitive performance and adaptive mindset. Every time you choose to focus rather than be distracted, you are rewiring circuits to sustain attention longer and engage higher-order processing more efficiently. Physiological state interacts directly with attention and mindset. Your arousal level, regulated by stress, energy, and neurochemicals, determines the brain's ability to sustain focus. Moderate arousal sharpens attention, excessive stress fragments it. Controlled breathing, brief movement, exposure to natural light, and brief novelty exposures can modulate your arousal and optimize attentional engagement. Similarly, fatigue, poor nutrition, or chronic stress reduces the efficiency of neural circuits involved in executive control. When attention is impaired, mindset falters. When mindset is rigid, attention is fragmented. Understanding and regulating these systems creates a brain state conducive to learning, decision-making, and creative problem-solving. Intentional practices can train both mindset and attention simultaneously. Setting clear goals primes your brain to allocate resources effectively. Breaking complex tasks into manageable steps increases engagement and prevents overwhelm. Periodically reflecting on progress reinforces a growth-oriented interpretation of experience, converting challenges into opportunities rather than threats. These practices align neurobiological systems, enhancing dopamine and norepinephrine signaling. which supports learning, memory, and sustained focus. Another key point is emotional regulation. Mindset is tightly linked to how the brain processes emotion. Negative self-talk, rumination, and fear of failure recruit limbic circuits that compete with prefrontal executive circuits. This diminishes working memory, reduces problem-solving capacity, and narrows attentional bandwidth. Training yourself to notice unhelpful thoughts, reframe challenges, and anchor attention to the task at hand strengthens prefrontal control over the limbic system, preserving focus and optimizing cognitive output. Finally, mindset and attention govern not only what you can learn, but how creatively and flexibly you apply knowledge. When attention is directed and sustained in service of a growth-oriented mindset, your brain can integrate information across domains, make novel connections, and solve problems in adaptive ways. Without this alignment, even well-encoded information or strong neuroplastic capacity may remain underutilized. Your potential is unlocked, not just by knowledge or practice, but by the dynamic interaction of mindset, attention, and physiological state. In essence, mindset is the lens through which your brain interprets experience, and attention is the tool it uses to act on that lens. Together, they regulate neural resources, determine learning efficiency, and shape the trajectory of your cognitive development. By cultivating a growth mindset, directing attention deliberately, and managing internal states, you can optimize the brain's functioning, strengthen learning circuits, and enhance every dimension of performance. The brain is adaptive, responsive, and primed to change, but only if you guide it consciously with the twin levers of mindset and attention. Your brain is not simply the organ that you inherited or a static system you must accept. It is a dynamic network shaped by your habits, your environment, your attention, the skills you choose to practice. By understanding how it works, by optimizing how you treat it, and by activating your capacities deliberately, you unlock a new level of brain power. So right now, imagine yourself 6 months from today. You've been consistent. You've applied the principles. Your brain feels sharper, your attention deeper, you're learning faster. That version of you is within reach, and it all starts with the choice you make today. Thank you for joining me here on Brain Encoded. If you're serious about elevating your brain, commit to one step right now. And if this video resonated with you, hit subscribe, turn on notifications, and join the journey. Until next time, train your brain, free your mind, unlock your potential,